Okay, section 2.1, talking about linear equations in one variable. So we have three things to talk about in this section. The first of which is we need to be able to decide whether a number is a solution. Number is a solution. And then after that, we need to be able to solve linear equations. And then finally, we want to work on recognizing two specific types of linear equations, and those are identities, which we'll talk about, and equations. I'm going to abbreviate here. It's just EQ with no solution. So those kinds of equations show up in two very distinct ways. So let's start by defining an equation. So an equation is nothing more than a statement that two things are equal. Now for us in math class, it usually takes the form of two expressions separated by an equal sign. And that's its basic function, is you take two things and you set them equal. That whole thing together is an equation. So the equation that we're focusing on, the type of equation we're focusing on, is our linear equations in one variable. So a linear equation in one variable is an equation with only one variable and no exponents on that variable. So we're not going to have any x squareds or x cubes or n cubes or s cubes or s to the fifths or y to the ninth. It's nothing like that. And it can be written as ax plus b equals 0. Now a and b are constants, and the only extra requirement here is we don't want a to be 0, because if a is 0, then we just have b equals 0, and unless b is 0, that's a fallacy. So I got a couple examples here written out. 3x equals negative 15 is an equation, a linear equation. 7 minus y equals 3y. 4n minus 9n plus 6 equals 0. All of these are equations in one variable. And notice the wording here in our definition. It can be written in this form, not necessarily that it needs to be. So none of these are actually written that way. But if we simplified and moved stuff around, we would be able to write it in this form. So we're going to take a look at a couple examples here, and then there's practice problems for you to try out on your own. We're going to determine whether negative 15 is a solution of x minus 9 equals negative 24. So the easiest thing to do here is just substitute our number, our potential solution, in for our variable. So negative 15 minus 9, does that equal negative 24? And hopefully we can see that yes, this is indeed negative 24, so this is a solution. Our answer is yes. So in this next example, we have two x's. We put our value that we're checking in for every iteration of that variable. So this is 2 times 5 minus 3 equals 5 plus 3. 2 times 5 is 10 minus 3 equals 5 plus 3. Now, we can probably make the statement of whether this is a solution right here, but if you're ever not sure, just simplify and ask yourself, does 7 equal 8? The answer is no. So, no, this is not a solution to this equation. Okay, so there's two here for you to try on your own. We're going to move on to properties of equality. So these are what we use when we solve equations. And you've probably used these. Actually, I would venture a guess that you've definitely used these properties. You just maybe didn't call them this or didn't remember that they were called this, depending on whether or not your last algebra teacher taught you this. So the addition property of equality says if A equals B, then A plus C equals B plus C. So if I have two things that are equal and I add the same thing to both sides, the result is also equal. And this is how, when we solve equations, we'll show in the bottom down below here, that's when we add things to both sides or subtract things from both sides. It's because of this property. And the multiplication property is very similar. It says if A equals B, then as long as C is non-zero, A times C equals B times C. So just like with addition, we can multiply or divide by the same thing on both sides and maintain equality. So in these next two examples, actually we've got a couple examples here and then some more practice. I believe there's 4 examples we're going to work together. We're just going to solve this equation. So adding is the same as subtracting if you think of adding as just, or subtracting as just adding a negative. So we can subtract 5 from both sides. We do that from both sides of the equation, inducing this property, maintaining our equality. We have 2x equals 4. And then division is the same as multiplication if you think of division as simply timesing by a fraction. So we times by 1/2, times by 1/2. 1/2 times 2 gives us x, and 4 times 1/2 gives us 2. So our answer is x equals 2. Now when we have a problem like this here, in this next one, 0.6 equals 2 minus 3.5c, you can solve this with fractions, or with decimals, not fractions, I apologize. But we can also just eliminate the decimals by multiplying the whole thing times 10. So this 10 goes to every single term, distributing it out. And so on this side we'll have 6. On the right side we'll have 20 minus 35c. And now we can solve this just like we did the first one and not worry about decimals. So I'm going to subtract 20 from both sides and get negative 14 equals negative 35c. Divide by negative 35. Whoops, don't need two negatives. Negative 35. And we have c equals negative over negative makes it positive. 14 over 35. However, we're not done because 14 and 35 share a common factor, so this can be reduced, dividing by 7 down to 2/5. And that is our final answer. So, moving on to the next page, we have a couple more examples. That's our next packet that you saw there. So the next example looks a little different. So when we have equations like this, we have to always remember our order of operations, PEMDAS. Remember, it's parentheses, exponents, multiplication, and division are equal weighted. Whatever comes first, addition and subtraction, equal weighted, whatever comes first. So because we have these parentheses, we need to distribute that 3. We have 3x minus 9 equals 5x minus 9. And add 9 to both sides. 3x equals 5x. Now here's what we don't do. We never divide by a variable because we don't know what x is, and there is one number that we're not allowed to divide by. We all know that to be 0. It's the only number in existence you're not allowed to divide by. So on the off chance that x is 0, and we do that division, we end up with something nonsensical. And so what we do is we subtract, doesn't matter which direction, I'm doing this one, 3x from both sides, and we get 0 equals 2x. Now we divide by 2, and we get x equals 0. So our suspicions were confirmed here. X is 0. If we divided by x, we would have 3 equals 5, which doesn't make sense. If we divided by x here, we would have 0 equals 2, which doesn't make sense. And those don't make sense because we were dividing by 0, which allows a nonsensical answer. So make sure you never divide by your variable. Always divide by your numbers. All right, in this last little example, we have y over 3 minus y over 4 equals 1 over 6. I'm going to rewrite that so it's a little bit bigger. So just like with decimals, we could handle this with fractions, but if you're like me, you don't like fractions that much. So what we do is we find our least common multiple of all of our denominators. And so 3, 4, and 6 all factor into 12. So I'm going to multiply by 12 on the outside. I'm going to distribute that just like we did with the decimal to each term. 12 over 3 equals 4y. 12 over 4 equals 3y. 12 over 6 equals 2. And so 4y minus 3y equals 2. Simplifying, 4 minus 3 is 1y equals 2. Now, of course, we could have solved this with fractions and left the fractions in there. But again, like I said, if you're like me, you don't like fractions that much. So there's some practice problems here for you to work on. What we're going to talk about now is solving a linear equation. The steps basically describe what we just did in a quick little step-by-step thing. So the first thing that we want to do is clear all fractions or decimals by multiplying by an appropriate number. For example, the least common denominator, the LCD, like we did up here, or by the correct power of 10. So once that's done, the next thing we do is use distributive property and combine like terms. To simplify. We want to do that as much as possible, so that's up here, simplifying. Right here, this was a simplification step, 4y minus 3y. And then the final step is to use the properties of equality to isolate the variable. And then the final step is to check your solution. Now, we didn't do any checking in the 4 examples, but I encourage you on your first few, and especially if you're having trouble with any problems in the homework or in the practice, to make sure you're checking your solution. That will tell you before you submit an answer whether you have the right idea or not. And if you are not getting a correct statement when you check your work, just like we did at the beginning, when we checked those values, you know you need to go back and work on a few things. So I got a couple more examples, some harder problems, a little bit harder equations that I'm trying to use all of the steps here. So this first one is x plus 5 over 2 minus y minus x over 2. Don't know why I have a typo there. So x plus 5 over 2 minus x over 2 equals 1 over 8 times 15x plus 3. So we have to do a lot of things here. First one is clear the fractions. So I have a 2, a 2, and an 8. So I'm going to multiply everything by 8. We're going to distribute that 8 to all 3 terms. And we're going to have 4 times x plus 5 minus 4 times x equals 15x plus 3. So now we have step 2. We need to use a distributive property. Distribute that 4 to both. And we have 4x plus 20 minus 4x equals 15x plus 3. 4x minus 4x cancels out. We're combining like terms. And we have 20 equals 15x plus 3. So now we're into our final, second to last step. We're going to subtract 3, and we have 17 equals 15x, divide by 15, and x equals 17 over 15. And that's our final answer. On the next one here, we have some decimals. So I have 1 decimal place here, I have 1 here, I have 1 here, but I have 2 here. So when you're multiplying by an appropriate power of 10, our goal is to get rid of all the decimals. So if we just times by 10, we'll miss this one here. So we need to multiply everything by 100. And you may be thinking, whoa, that's a big number. The nice thing is when you multiply by powers of 10, you're really just adding zeros. So the actual arithmetic in the solving becomes not so bad. So again, distribute that to everything. So we have 30x plus 100 plus 100 plus 10. And this would be, yeah, plus 10 equals 270x minus 2. So I'm going to minus 30x here. And at the same time, I'm going to add 2 to both sides. So those cancel, and we have 12 equals 240x. We're going to divide by 240. And we have 12 over 240 equals x. Now 12 goes into both of these. So 12 goes into 12 once, and it goes into 240 20 times. So our final answer is 1 over 20. So one thing to be prepared for is, even if your problem doesn't have fractions, or you get rid of the fractions, or get rid of the decimal, that doesn't prevent your answer from being a fraction. So keep that in mind. Just because you don't see fractions doesn't mean you don't have fractions. So those are 2 little bit more challenging ones. There's a couple more practice problems after this for you to work out. And then the last 2 examples are special types of equations. So we're going to identify each of them after we solve them. So this first one, just following our steps, we need to distribute the 3. And we have 3x plus 5 equals 3x plus 6. Now, here, if we subtract 5 from both sides, we get 3x equals 3x plus 1. Well, the only other thing we can do next is subtract 3x. And when we do that, we get 0 equals 1. Now, we all know that that's not true. And so this is an equation that has no solution because we have a false equality. So since this is false, we say no solution. Because 0 can never equal 1. So when you run into this, this is how you know you have no solution. Additionally, when you're checking your work, as I hope that you are checking some of them at least while we get the hang of this, if you get something like this, that means that your answer was wrong, just like at the very beginning. Okay, so this last one here, we need to distribute the 6. So we have 6x minus 4 equals 2, plus 6x minus 6. Collect like terms, 2 minus 6 is minus 4. 6x minus 4 equals 6x minus 4. Well, this is always true. And even if you didn't quite catch this and you kept going, and we add 4 to both sides, we get 6x equals 6x. Also still true. And even if you didn't quite catch that and you subtracted your 6x's, we get down to 0 equals 0. And 0 is always equal to 0. So this is what we call an identity. And it's called an identity because one expression, 6x minus 4, identifies itself, the equals, as 2 plus 6 times the quantity, x minus 1. They are 2 different expressions, but they have equality. So they are an identity. And this means that there are infinitely many solutions. So you can think of these two things as when you get something that's false and never true, there's no solution. And when you get something that's always true, 0 always equals 0, you have infinite solutions. All right, that's the end of 2.1.